What's up, guys? This is Waleed. Today's problem is the Compton Scattering. So the main thing I'm going to be focusing on is we're going to be using this. We're going to be using theta in each question. So the photon just barely grazed through the electron, so the angle deflected as theta can be considered zero. What is the wavelength of the outgoing photon after the collision? So the equation we'll be using is lambda minus lambda. So this lambda is the scattered one, so after the deflection it's going to be equal to h divided by me c 1 minus cosine of theta. Okay, this theta is this guy in here. Okay, and to make it easier, this phrase is going to be always equal to, so let me just write in here, divided by me c is going to be always equal to 2.4 e to the negative 3 nanometer. Okay, so for this question they want to consider the cosine to the theta to be 0. That means the cosine of 0 is 1. Cosine of 0 is 1, right? So that means this goes to 0. Then lambda prime minus lambda is going to be equal to 0, which can make lambda prime is going to be equal to lambda. And lambda they gave us 0.66 nanometers, which is going to be the answer. Cool. What is the energy of the outgoing photon? So the energy is going to be equal to hc divided by lambda. And we're going to be using h is going to be equal to 6.626 times 10 to the negative 34. And this is joules per second. And then times the speed of light, 3 times 10 to the negative 8. This is meter per second. Second like that. Divided by the 0.66, the wavelength, times 10 to the negative 9. This one because it's in nanometers. So what I got for this, let's see if those guys cancels. This is in meters, and this one will cancel with this. So yes, it's in joules. So what I got for this guy was 30 negative 17 joules. Just make sure. Yes, 30 to negative 17. So now assume the photon deflects off a small angle of 32 degrees. What is the wavelength of the outgoing photon? So doing the same thing, I'm just going to take to the other side already. Plus 2.4 e to the negative 3 1 minus cosine of 32. Cool. So this guy is 0.66. Let me just 0.66. So for this, I got 0.6603 nanometers. Cool. What is the energy of the outgoing photon? Number 4. Same thing. E is equal hc divided by lambda. And then use the same numbers. So 6.626 times 10 to the negative 34 times 3 times 10 to the 8th divided by lambda, which is 0.6603 times 10 to the negative 9. And for this guy I got energy was 3.0104 electron 6, I mean e to the power. So this is 10 to the power 16 in joules. So next, assume the photon deflects off a larger angle, which is 114. What is the wavelength of the outgoing? The same thing, lambda. I'll just write the numbers in, which is 0.66 plus 2.4 e to the -3, 1 minus cosine of 114. And for this guy, I got, make sure you get 0.66329 nanometers. Cool. The energy of this photon, we do the same thing. We use this equation again. So for this guy, I got number 6, 2.996 e to the -16 joules. So now, let's say the photon hits straight on, so that it deflects right straight back, so it goes back. So let's say this is the photon, and this is the electron. This is P, this is E. It hits it, and then after that, it just goes back. So what's the angle in here? It's 180 degrees. Cool. Okay, so phi is going to be equal to lambda plus 2.2, what was it? 2.4. 1 minus cosine of 180. Okay, cosine of 180 is -1, so -1, so it's going to be 2. So lambda will be equal to 0.66 plus, so now this is 2, so let me just write this, e to the -3 times 2. Okay. Let me write this in a better way so it doesn't make confusion. 2 times 2.4 e to the -3. Okay. And for this guy, I got, let me see what I got. I got 0.6648 nanometers. Cool. What's the energy of the outgoing? We'll do the same exact thing. Let me just write this. 6 times 10 to the -34. 3 times 10 to the 8th. 6648 times 10 to the -9. For this one, I got 2.99007 e to the -16 joules. Okay. So, summarizing the results of the Compton scattering interaction, we say that the greater the deflection angle, the greater the change in photon. That makes sense. So, this question is just basically repeating number, what was it? The full deflection of this guy in here. So basically saying that if it's it, like what's the greatest angle to have the greatest wavelength, maximum wavelength, which, to make sense, if this one, the cosine of 180 is -1, that will only make sense because it doubles it, doubles the 2.4 e to the -3. So we're just, let me just redo it again. Plus, now equal lambda plus 2.4 e to the -3, 1 minus cosine of theta. So to make the biggest change in this guy, the theta has to be the biggest, or this term has to be the biggest, which makes sense if the theta is equal to 180, which will make the cosine of 180 equal -1, which makes the whole term in here is 2, so we're doubling it. 2.4e -3 plus lambda equal lambda phi. Okay, so for this one I got just the same answer as the one before, 0.6648 nanometers. Cool. Okay, number 11, results. Okay, we get number 2. The less massive the target particle, the greater the change in photon in wavelengths. Let me make sure that that was it. Yep. This one. This one's yep. Alright guys, if you guys need any question or if anything confusing, let me know. I'll try to help you guys. So see you guys, good luck.